Hello 108 students, Mr. McHugh here with you, finishing up page 3 of section 5.4. This is our last video for it, and we're going to go ahead and practice a couple problems here. 6D in my class notes here looks, doesn't look complicated. It's just a binomial and you are going to square it. And so it's a repeat of the last problem. I want you to realize because they look a little tougher, don't let that mess with you. You still got the first term, which is 3r, and the second term is minus 5x. And so you could use the shortcuts, okay? You could also use FOIL, first outer, inner last, okay? But let's try the shortcut. The shortcut says take the first term, which is 3r, and square it. Then next, multiply the first term times the second term and double it. And that's what I did here. Minus 3r times 5x and double it, times 2. Finally, take the second term, which is 5x, and square it. And even if you stick the negative in there, it doesn't matter, because the negative or a positive squared is going to give you a positive. So 5x squared is 25x squared. 3r squared is 9r squared. Over here, you get negative 3 times 5 times 2, which turns out to be what? Negative 30. R and x, you multiply them out, and there's your answer. Okay, next problem, a little tad tougher. You see this, it's a binomial and it's cubed. The way to do this is to take advantage of our exponent rules. Whenever you have raised to the third power, you could break it down as the base is x plus y quantity squared times x plus y what raised to the first. Why am I allowed to do that? Because when you multiply by the same base, you add the exponents. 2 plus 1 is 3. Okay, so I broke it down, and what that allows me to do now is to look at the quantity x plus y squared and treat that with our special products rule or use FOIL. And again, you could always write it as x plus y times x plus y and do FOIL on it, but I'm going to try the shortcut. So here we go. Take the first term, square it, multiply the two terms, x times y, and double it, producing 2xy. Take the second term and square it, multiplied by the base, which is x plus y. Okay, now that you've got that, it becomes a lot of work here, but what you've got multiplication between a trinomial and a binomial. You're going to use double distribution property. You're going to take the x multiplied by each of the terms, and that's what I did here. The result is x to the cube plus 2x squared y plus xy squared. Go back and study that. Make sure you follow those nitty-gritty details there. Next, take the y and use the second half of the distributive property. A lot of times I show that going across the top and across the bottom, but you're multiplying the y times each of these three terms, producing this result, this trinomial. And then what you have to do is you get a lot of x's and y's and squares. You just got to pay attention. Combine like terms, CLT. You've got x to the third, you bring it down. Y to the third, you bring it down. You see 2x squared y, and you see 1x squared y. Combine them. 1 plus 2 is 3. That's where that came from. Same thing over here. 1xy squared, 2xy squared, add up to 3xy squared. Okay, so that one gets a little, I call it tongue twisty when I'm talking about it, but just be careful with all the nitty-gritty multiplications going on. Okay, now objective 6 here, the last objective here we're going to work on is naming convention or protocol with functions. Again, you're going to multiply polynomials. We're going to use our parentheses, and this time you're going to see two functions with the names f of x, and the second function is going to be g of x. We're going to multiply them together, and so for the notation, we're going to say f, g, and it's assumed to be multiplication going on there. You do not necessarily have to put the dot there, but that's what's going on relative to the x variable. So x is your input, and the result is taking the x and multiplying it. Okay, so how do you say this? You say f times g of x. That's how you would phrase that notation. F times g of x. Now that of just means of the input variable x. Okay, so they're going to give you some problems. And you've been doing these problems before. Now they're going to put them in function notation. So f of x is 3x plus 4, g of x is 2x squared plus x in my example 8. What happens if you are asked to multiply them? That's what they're asking you to do. So break it down, substitute the binomials, and multiply them. So what technique do you use? FOIL, first outer, inner last. So go ahead and draw it. 3x times 2x squared, 6x cubed, outer. 3x squared, inner. 8x squared when you multiply. Finally, 4 times x is 4x. And can you combine like terms? Yeah, remember, same base, same exponent. So 3 plus 8 is 11. X squared plus 4, and you got it. Okay, now they like to do these in two parts. They like to go through the notation of multiplying relative to the x variable. Once you get that result, they'll ask you what is it when x has a specific value of -1. All you're going to do is take that -1, substitute it into the result that you found, and grind away with a little plug and chug and multiplying them out. So -1 cubed is -1, 1 squared is a +1, 4 times -1 is -1, 11, -6, add them all up, and you get the answer is 1. Okay, hey, Mr. Q here. We are wrapping up page 3, and when I see you for the next video, we will be starting section 5.5, page 1. Okay, take care. Bye.